So there's two ways to do this problem, right? We're kicking a football straight up in the air. We can make VF 0, as Keon says,
Or negative 13.
or negative 13, right? In each case, we have to treat that a little bit differently. Either we say he shoots it up to the top, where V is 0, we can make that VF. But is that the whole time in the air?
No, just
No. So we're going to have to double it then. And that's fine. Or we can say when it comes back down at the end, it will be going negative 13, right? So we could say VF equals negative 13. Do we have to double it then?
No.
No, then it's the whole time. Okay, so what formula will we use? So you can say VF equals VI plus AT. Do we know A?
Yes. Negative 9.8.
We're just in the air, no forces, nothing except for gravity.
Ali's the force.
So A is equal to negative 9.8. Ali is a force, that's true.
This is an upside.
So if we want to solve for time, we're going to do VF minus VI over A, and that should give us our time. And so we could do negative 13 minus 13 is negative 26 over negative 9.8, so about 2.6, yeah?
2.65.
2.65?
235.
Around 2.6 seconds is our time. Okay. Underneath that, oh, how many of you got that? Good, that's excellent. You're still working on it? Okay, now we're gonna kick the ball for some distance. We're gonna kick it at 26 meters per second at an angle with the ground of 30 degrees. And the question again is, how long is the football in the air? Opposite over. What's the saying? So katoa. So nice outside. We should go outside and kick some real footballs.
You should kick Ali Reza.
Pretty cold. I would never kick out of it.
Thank you.
Is the adjacent going to be the answer?
Question, Finley. This is my initial velocity, yes? So this is the whole issue here. My VI is 26. But is that the VI I'm going to use in my equation? I cannot. Why can't I use this 26 as my VI?
Because it's affected by another direction.
What's going to affect that velocity?
Ali Reza.
Only gravity, right? Gravity pulls in what direction? Down. So we can't use this because only part of this is vertical, right? What's the other part? If it's not vertical, it's horizontal, right? So when we kick a football at some angle, we kick it with a horizontal initial velocity, which I would call VIX. And also we kick it with a vertical velocity, which I would call VIY, because it's in the y-axis. So we can figure these out with trig, but just before we figure it out, what's going to happen to VIX as the ball moves through the air?
It's constant.
Good, good. VIX does not change. So the horizontal velocity all the way through is just gonna go constant velocity. We're gonna negate air resistance. We're not worried about that. But what happens to this velocity?
That's like,
You know, it's pointing down. Yeah. Gravity is working against this, right? So it's gonna slow it down and stop and come down, just like it was in this question. So, if you do your trig, you'll find out that this VIY is equal to 13. If you do 26 times the sine of 30, you are going to get this. And so this is VR. If I call this the resultant velocity, you could just call it V or VI, whatever you want. But it's this times the sine of 30, and that equals 13. What's this one going to equal, just out of curiosity?
22 plus
15.
But what's the formula?
cosine of 30.
This is VR cos of 30.
22.
So this is kind of the simple way to do it. If you're given the hypotenuse, the angle, the side that's opposite your angle is hypotenuse times the sine of the angle. So in this case, it's V sine theta. The one on the bottom, the flat one, is V cos theta. And if you do your little trig, you'll find out that that works. So if you're given the hypotenuse, this is the hypotenuse times the sine of the angle, and this one is the hypotenuse times the cos of the angle. Because it's adjacent, this one is opposite. Kind of a quick way to do it. Okay, so this is 13 meters per second. Right away, when you saw that, what did you notice?
It's half 26.
It's half of this, yeah. That's because the angle is 30 degrees. But what else, where do you recognize this number from? Eddie?
The other question.
The other question is the same. So Eddie, what's the time in the air?
2.6.
You got it. So my T is 2.6 seconds. I don't even have to calculate it. You can if you want to, but you'll be doing the same thing over again. Right? Because the only thing that's going to affect how long this football is in the air is the vertical velocity. Because Soren, what is that vertical velocity being affected by?
Gravity.
Only gravity, right? Gravity doesn't touch this one. It only worries about what's straight up and down. So as soon as you get this VI, in the Y direction, the vertical one, bless you, Madison. As soon as you get that, now you're home free. You've already done these kind of problems before. You just put the acceleration into this velocity. Kim?
Does the angle matter at all or no?
Yeah. If I go 26 at 60 degrees,
Sine of 30.
what's going to happen to my Y direction velocity?
Higher initial velocity.
It's going to be bigger, right? So it's going to spend more time in the air. If I go like 1 degree, what happens to my Y velocity? It's teeny short, right? It's not going to stay in the air very long. So if I change my angle, I change this, which then is going to change my time in the air. Finley?
Why is your VI on the y-axis not negative 9.8?
My initial velocity is 13. My acceleration is negative 9.8. And that part doesn't change. My A is always negative 9.8, but this is straight up and down, right? So this is only vertical. Show me with your arm what vertical means. This, right? Show me horizontal. Show me x-axis. Show me y-axis. So this VI is the one you need to find the time, because the only thing that affects the time is gravity. This thing stays the same. It just stays the same the whole time. Okay. And my acceleration is negative 9.8, but that's only acting on my vertical velocity. Okay, so my next question is for that one. I'm gonna erase this one. We already did this calculation. So with this football kick, how far down the field does the ball go?
So now we use the X.
So take a couple of minutes and try to sort that out.
Why do we use it?
This use the time and the
How are you gonna find out how far
It's a series of this.
it goes horizontally?
I think
We will use the VIX because that's the
No,
horizontal.
don't worry about the bounce.
Horizontal velocity. You already did this in the.
It's the horizontal, it's always constant, and you just plug it in.
We did this in the Michael Jordan.
yeah.
Nice.
If it's horizontal, so it has no acceleration, you just, you're just use the formula of acceleration and
You can use one of these formulas and you can make acceleration 0. What you're gonna end up with is this. If you have 0 acceleration, it's just v equals d over t. So what do you want to solve for in this case? D. And we want d in the x direction. And that's going to equal vt, but which v? Vx, right?
The horizontal.
Yeah. Is vix and vfx, is the initial horizontal velocity and the final velocity different?
No.
No, because it's constant.
They're the same. This number will never change. It'll stay the same all the way through. So you don't even have to worry if it's initial or final because it's the same number. But we have to calculate this, so what is this? 22.5?
Yeah.
Is he
Times
right?
that by 2.6.
Who doesn't know how to do that?
I don't know how to.
Don't be shy.
I don't know.
Who does know how to do it?
What? Do what?
Wow, I got like 4 hands.
I don't know how
Who's
to
too
do it.
embarrassed to say whether they know how to do it or not? Who's too tired to put their hand up? Who's not going to put their hand up no matter what I say? Okay. There's like half of you that didn't put your hand up in any of those. Okay, take your calculator. Everybody grab your calculator. In order to find this side, horizontal side, we have the hypotenuse, which we know. And we're looking for, which side is this? This is the adjacent side. Thank you, Finley. So if you're working with adjacent and hypotenuse, which trig function are you going to use?
Cosine.
Cosine. So the cos of theta is equal, it's so ka toa, right? So it's a over h, ka.
So times.
So we want to find a, right? We want to find the adjacent side. We already know the hypotenuse and the angle. So we're going to move the h up here. And we're going to say h cos theta equals a. That's what we're looking for. So for us, our h, our hypotenuse, is 26. And we're going to do cos of our angle, which is 30 degrees, and that equals a. This, when you write them beside each other, that just means you're multiplying. So on your calculator, punch in 26. And then if you're using a graphing calculator, you can just hit cos. If you're not sure, hit times, and then do cos of 30. And you should get 22.5. Now, if you don't, you're either doing something wrong or your calculator might be in radian mode. Radians are a different measurement of angle. So you should get 22.5 meters per second here. And this is equal to VIX. Yes, Mo?
So for the cosine, if you want to find the h and you have the a, how do you do it then?
Yeah.
If you want to find the h, you have to put the h up here because you don't want it on the bottom. And then the cos theta comes underneath. So you would do the a divided by the cos of theta. That would be the hypotenuse. That's if you know this number and you need to find that one. Yeah. We're doing the opposite right now. But good question. Yes.
So will the time be the same for the vertical and the horizontal?
Yes. Ali just asked a good question. If you kick a football, boom, will the time vertically be the same as the time horizontally?
No.
What?
Oh, yes, yes.
Yeah, why? Because in reality, there's only one ball, right? It doesn't come apart and one goes vertical and the other goes this way. It doesn't do that. It's all just one and it hits the ground at the same time. So us splitting up these components is something we do in physics because it's only this part of the velocity that's affected by gravity. So we use our negative 9.8 vertical acceleration on this component of the velocity. And the flat horizontal component of the velocity stays constant. It doesn't accelerate at all. But in reality, this is all in one thing, right? You throw your football and it goes, and it lands. And it's obviously going to land at one time, right? So the time is the same for both. Okay.
Are we gonna be doing like how long it will roll after that?
How long what?
Like how far it go after that? Are we gonna do anything like that?
No. You could do it in a lab when we do our lab. You could look at that part. But that's dependent on a whole bunch of different things. If you're a golfer, you know that when your drives in the winter are a lot shorter than your drives in the summer. Why is that?
Air resistance.
Not really.
The ground, and it's more like sticky.
What's the ground in the winter?
Harder.
Soft and wet. And the ball lands and it goes bleh, and it just stops. What does it do in the summer?
Rolls.
It hits and it bounces and it goes ding 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 ding. I hit a drive one time about 800 yards.
That's impossible, Mr. Just
No, it's not,
I
Marco.
drove on
You want to know where I did it?
On the
I did it on a country road.
Where's the video?
Oh, but you have to hit it straight though.
Yeah, it was straight. I didn't even hit it very hard. It went ching ching ching
Video.
ching, and it rolled all the way down the road.
Did you find how hard you hit?
I won some money doing it.
Yeah.
Did you find out how hard you hit it? Like having
Can you find out how?
like the initial velocity of your swing? Can you find that out?
Oh yeah,
Of course.
yeah. You can do that. You have to know the general angle. You can usually find that out. Nikki, sorry.
What numbers did you plug in to get the time?
Oh, good question. There's two ways to do it. You can put in 0 and you can put in 13. And then you can put in negative 9.8. But then you'll get 1.3, so you have to double it. Or you can put in negative 13, because that's what it's going to be when it comes down. And it's positive 13 on the way up, right? And A is negative 9.8. Of course, this is only vertically, right? And you're going to solve all that for T. So you do negative 13 minus 13. Should I do it?
Yeah.
Okay. Sorry, sometimes I skip steps and I shouldn't do that. I'm going to subtract the VI over, and then I'll be left with AT. So I'm going to divide the A
Wow.
underneath, right? So I have negative 13 minus positive 13. over negative 9.8. I'm gonna be honest, I just did this in my head. I just round this to negative 10. So I know this is negative 26 divided by 10 is 2.6. It's close at least. Okay. So we know how long this thing's gonna be in the air. So how are we gonna find out how far it went?
Times it with the.
Jeff. Good. What was my Vx? 22.5.
Times 2.6.
Is this the final velocity or the initial velocity? It's both, right? It's all the time 22.5. And on the flat horizontally, it does not change. We know it's in the air for 2.6 seconds, about. And so what's that, 50 or so?
58.5.
50,
8.5.
let's say 59. And that would be in meters, right? That's a pretty good punt. Yes, Madison.
Why would you find the distance of the 26 meters per second?
So that's not.
Oh, well, you can, but that's really complicated. Can I erase some of this stuff? Does anybody want to take a picture of this yet? Take a picture if you want. I will try to post this video, but it might take me a while.
What would the function be if you were to calculate with 26?
Well, it's quadratic, it's parabolic.
We're just not do further. Let's leave that in the past.
What are we talking about here?
Can I erase some of this stuff now?
Can we actually do it in 26?
Am I the only one that doesn't want
Can we try to actually do it?
Math class, somebody was in terminal
What does that mean?
So Madison asked a good question. Why don't we just find the distance in the 26, and then we can do the d over 26 and it will give us our time, right? But the thing is, this is going to travel in a shape called a parabola,
Oh my god.
right? So it's going to be tricky to find that displacement, right, in that direction. And the other thing is that this velocity, this 26, is it going to remain constant?
Oh. Terminal.
What is it going to be right at the top? No, not 0.
It's max.
It's gonna be.
Yeah?
30. That's what it comes to.
Terminal.
22.5.
And then velocity horizontal is gonna be 26 meters per second.
What happens
So,
to your tangent line?
It's
What is
only
the tangent?
going at the very top.
Where is that?
The vertical is 0, right?
Is that a tangent?
So this part is now 0. So it's only this bottom part. So we said that initially this was 13, right? And this was 22.5, was it?
Yeah.
So up here, there's 0 vertical velocity. This is 22.5.
But that's like
Because the vertical is 0, it only has horizontal velocity. What about right here, if you had to guess? What do you think the velocity would be?
terminal.
6.5.
Say that again?
6.5 vertical, 22.5.
Well, this is going to be 22.5. You're right about that.
And then 6.5.
The vertical will be 7.5.
Is that
Yeah, you could do half. You could do half.
It looks like half.
More than half.
It would be a little bit. It wouldn't be exactly half, but we'll go with that.
7.5.
So let's go with Soren's guess, and we'll say about 6.5. It's going to be between 13 and 0, right? So you could find out that velocity, but it's not going to be constant, right? It's going to go from 26, and it's going to be less, and then it's going to be 22, and then it's going to get more, and then it's going to be 26 at the
Or do you
end.
like the tangent line?
What was that name?
What we're trying?
Yes. That's right.
Are you gonna do that
So,
like this
Madison, this is why we don't do it this way. It's complicated.
That's what the function was. Did you?
For those of you who are trying to grasp this, This is actually a really good exercise. Okay, so you're seeing this velocity shrink, just like it does if you kick it straight up, right? You're just slowing down, going to 0, falling back down, speeding up on the way back down. So on the way back down, you're gonna have still the same 22.5, but this is gonna be down, I don't know, 7 or 8 or 4 or 5 or whatever, and you're gonna have some velocity this way. And at the very end, you're gonna have still 22.5, and this is gonna be, as Soren says, negative 13, and that's gonna be 26. You can't say this is negative 26 because it's on an angle, but it's gonna be the same because this is gonna be a mirror image. Okay, so the concept you need to take in is that the vertical velocity is changing, it's accelerating. But that's okay because you guys know how to deal with that already. You have your 3 formulas. You know how to do up and down throws and drops and stuff, falling off cliffs and that kind of thing. So the only extra step with this projectile stuff is really just the trigonometry of finding out these velocities in the beginning. And once you know that, you know this is my vertical velocity. So that's my big 3 acceleration formulas. You already know how to do that stuff. This part is even easier because this is not changing at all. So you don't even need the big 3. All you need for this, is just V equals D over T, right? So maybe use that to solve for time, or maybe use it to solve for displacement or whatever. Depends on the kind of problem I give you. What I really want you to take in is that when you have a projectile motion, so I might say a football being kicked, I might say you throw a rock completely straight. You fire a cannon off of a cliff, and it goes straight and falls down. I might say you have a fire hose from the ground, and it's going up to a building. It's all really the same thing. You have to separate it into vertical, which is accelerated by gravity, and horizontal, which is not accelerating at all. It's just staying constant. And once you take that in, this stuff actually gets pretty easy. How many of you, be honest? Okay, I'm gonna make you do something really embarrassing, I'm sorry.
Embarrassing.
Put your fist on your desk, like this. Your thumb in. Now remember in elementary school we played heads up, 7 up? You're gonna put your elbow like this on your table, and I want you to put your eyes into your elbow. If you need help with trigonometry, put your thumb up right now.
Only a bit?
Yeah, then just put it up half. Okay, put your thumb back down again, and put your head up. Okay, good. So a fair number of you are still kind of working with trigonometry. And so what I'll do is I'll post a video of just the basics, like just how to find these sides and stuff. Because I know it's new, and you haven't done that much math. Hey Eddie, can you let Madeline in?
How long has she been there?
I'm gonna stop the video here just because we're kind of done this main projectile problem. We found the distance, didn't we?
The horizontal.
Yeah, the horizontal. So we call that the range. We call that the range.
Oh, it's called a range.
Yeah.